Ignition sequence start. 5, 4, 3, 2, 1. Liftoff. We have a liftoff.
Good afternoon, ladies and gentlemen. Welcome to the Schriever Spacepower series. I'm Charles Galbraith, Senior Resident Fellow for Space Studies at the Mitchell Institute's Spacepower Advantage Center of Excellence. The Space Development Agency is at the forefront of revolutionizing how the Department of Defense acquires, develops, and deploys next-generation space capabilities. The objective is to rapidly fill the proliferated warfighting architecture of small satellites that is more agile and resilient than any before. This is crucial for maintaining U.S. technological and warfighting superiority in an increasingly contested space domain. Given the importance of this mission, I'm thrilled to have Dr. Derek Tournear, the Director of Space Development Agency, with us today. Dr. Tournear, thank you for being with us. Welcome to the Schriever Spacepower series. Before I start diving into questions, let me give you an opportunity to make any opening comments.
Well, thank you, Charles. This is an exciting time, and that's a great introduction to the Space Development Agency. So, this time in history, we're just over 5 years old. And if you think about it, we have 27 satellites already on orbit that are demonstrating the mission. We're just about ready to launch our first tranche of proliferated satellites. That's over 126 satellites to be able to actually give tactical communication to the warfighter in real time. And then we're just around the corner after that of launching our Tranche 2, and Tranche 3 is about to be solicited. So what that actually means, we are focused, we at Space Development Agency, but just to make sure everyone's on the same page, are focused on providing real-time capability directly to the warfighter. And we're going to do that using two pillars. Pillar number one, proliferation. Hundreds and hundreds of these satellites, which is a completely new way to do things. And then pillar number two is that spiral development approach. Every 2 years, by hook or by crook, we're going to get those new tranches up there, those new spirals, to provide that capability to the warfighter. This is the first time we've actually been operating satellites, testing them out, just about getting ready to launch satellites. And then our satellites on Tranche 2 have just finished their design stage, and so we're starting to cut metal on those. For industry, the exciting news is we're just around the corner, just in the new year. So in January of next year, you can expect to see solicitations for the Tranche 3 satellites. So it's exciting times, and I'll even say that this week, we're actually testing in Norway, Link 16, with our allies in Norway. I've got some good news that we've had preliminary good results to show that we can go Link 16 directly down to some of the aircraft over there, and so things are working well. So it's an exciting time to be at the agency.
Awesome. Thanks for that introduction. I plan to dive a little bit more onto Link 16 and communications, but let me start with the iterative or spiral development that you talked about. SDA is really held up as a model now for constructive disruptor within the Department of Defense, largely because they're using a spiral development approach. So that's one of the reasons why you were presented with the Symington Award at this year's Aerospace and Cyber. Congratulations for that, by the way. But what do you think is working so well for SDA that might be scaled or translated to other existing programs, not within Space Development Agency?
Well, thank you. Yes, and it was quite the honor to receive that award from the Air and Space Forces Association at the Aerospace and Cyber Conference. And I think it is a testament, like you said, the way we have changed doing business within the Department of Defense is to focus on getting capability delivered as rapidly as possible. Our motto, as you know, is Semper Citius, which means always faster. But our unofficial motto is better is the enemy of good enough. You've got to get those capabilities in the warfighter as rapidly as possible. It's actually working very well for us because we're using technology that is mature and ready. It's been developed by the commercial industry, where we've just been able to make tweaks to that to get those capabilities to the warfighter, and that works really well for us. Now, if you look at how that could be translated, I will say that unfortunately, not everyone within the Department of Defense has been as forward-leaning at recognizing the success as the AFA. So thank you for that. But we are starting to get some forward momentum. If you look at other places within the department that are copying this model and it's working successful, the Space Force is developing a proliferated LEO and a proliferated MEO, medium Earth orbit architecture for the missile warning, missile tracking. And our friends at Space Systems Command are copying our model to develop that MEO track custody layer. So that shows where it's working quite well. But I will say, you will continue to hear people say that we're going too fast. We should slow down our spirals. There's a lot of people that believe you should end a spiral, have a period of time where you're operating that spiral before you start the next spiral. The problem with that is you're just going to slow things down overall. So you'll hear that. The other thing you'll hear is people say, you know, you can always get better capability if you're willing to spend more. So why not make the trade to buy a more capable system at the expense of cost? And our motto is, you know, better is the enemy of good enough. You've got to get that capability that you can afford to show that you can proliferate it and move at scale and push forward. The other thing, now that we've been more successful within the department at demonstrating this spiral development model, there's a lot of folks that are saying, well, you know, it's worked well up to this point, but you know what would even make it work better? And that's if they followed all of the standard requirements processes that everyone else follows and uses that to pull everything in. Well, you know, there's a reason that it's worked well so far. And so far, if it's working and if it's not broke, don't fix it. And so let's continue to keep pushing this forward. Now, that's not to say, as you and I have discussed, I don't think that everything in the Department of Defense should be acquired on this model, using firm fixed price contracts, which allow us to move at scale rapidly as possible, and proliferation, hundreds and hundreds of these capabilities. I think there is a time frame, just like in World War II, where you had the Liberty ships, which were the proliferated model to get the capabilities out as rapidly as possible. And you had the Manhattan Project that took the time, did things properly, pushed the edge to get the best technology that was available at the time fielded. You have those two models. You're going to have those two models now. Even in space, you're going to have models that have to be very exquisite capabilities to give you, you know, that edge on the enemy that you need. But then our model, which I think that the majority of the Department of Defense capabilities can be employed by proliferation and getting things out at scale.
Yeah, yeah. Well, certainly there's room for both, right? And there's no one size fits all solution to everything. You know, the critics who say you should take a break, hopefully they understand that there's a slowdown and a startup, you know, regaining your pace penalty when you stop. So hopefully they figure that out.
Well, some of these folks that say that, I'm not sure that you have a lot of people that study these things and do these that have never actually been responsible for delivery. So sometimes those nuances are lost, and so we'll see.
Okay, all right. I just know when I'm stopped at a light, it takes a while for me to get to move because the car in front has a delay and there's a delay. Anyway,
That's right.
Don't mean to take us down a rabbit hole. So let's talk about the RFI for Tranche 3 of the PWSA, Proliferated Warfighting Space Architecture. Can you lay out the difference, the distinction between Tranche 3 and some of the earlier tranches? Is it basically more of the same, or is there a specific capability or quantitative difference?
Sure. So Tranche 3 is special in the fact that that will be the first tranche that not only has to field new capabilities, but also has to replenish capabilities that are being decommissioned. So our satellites are designed with a 5-year lifetime. So 2 years into Tranche 3, after Tranche 3 is launched, our Tranche 1 satellites will be at the end of their 5-year lifetime. So we'll start to decommission those about the same time. At that point, we'll be launching Tranche 4, but we'll be reliant on Tranche 3 operations to backfill the decommissioned Tranche 1 satellites. So what you'll see there is you'll see a lot of emphasis on not only adding new capabilities and continuing to build out the model, but also making sure that we can have that continuation to pick up when Tranche 3 gets decommissioned. What you will see that's completely new, so you'll see a few things. So Tranche 3, the transport layer is broken down into 3 pieces. And my team, they know I have a difficult time putting together names and capabilities, so they did me a favor on this one. They named Tranche 3 transport layer Lambda, Upsilon, and Sigma. And you say, well, what do those mean? Well, here's the key. They did this for me. Lambda, L, Link 16. So the Lambda birds will be Link 16, very similar to what we're flying on Tranche 1 and Tranche 2. Upsilon, U, UHF, and S-band. So those we'll be doing the TAC SATCOM mission, which we started in Tranche 2 on our Tranche 2 beta, and then we'll continue to proliferate that on our Tranche 3 Upsilon. And then the Sigma birds for S, that's the advanced S-band. So that's what will be completely new on Tranche 3. And what that means is advances in waveforms and advances in new antennas, phased arrays for our antennas to allow us to talk to more radios at a time with the same satellite. So we'll demonstrate that capability. Another thing that we'll demonstrate for the first time, we have always been involved in alternative position navigation and timing. It's something that the Department of Defense needs. We need to have a way to provide position and timing information if GPS is jammed or degraded. But what we have always done in Tranche 1 and Tranche 2 is we have calculated a position and time signal on the satellites and then embedded that message into our comm network. So if you're on our comm network, you get that position and time. We had never broadcasted out. Starting in Tranche 3, we're going to, on a fraction of our satellites on Tranche 3, we're going to provide a lightweight signal service, PNT service. We're working with the Army on exactly what that looks like, but it will either be an L-band or S-band signal that goes out for things like munitions and things like that. When we say lightweight, it means very low processing is required to receive the signal.
Okay.
And so that's new. The other thing that will be new, and there's an RFI on the street, and we're going to go out with a draft solicitation early next year. We really want industry to tell us the state of the art and the state of the manufacturing readiness for a combined missile tracking, missile defense satellite. Up until this point, we have been flying a missile tracking satellite constellation. We used to call that our wide field of view. That allows you to do missile warning and missile tracking. Just for everyone's, we're all on the same page. Missile warning is launch detection. You know, the old school, now we can affect mutually assured destruction, let the president know we're under attack. Tracking is not only can we tell you that the missiles have been launched, but as they maneuver, we can tell the impact point. So we can tell the people downrange to prepare theater air defenses, or in worst case scenario, at least tell them to prepare for duck and cover. Defense takes that one step further and says, not only can we detect the maneuvering missiles, we can detect them to such accuracy that I could send that data down to an interceptor with no other sensors needed.
Okay.
Now, in Tranche 1, we're flying 28 of our tracking satellites, and we're flying 4 of the missile defense satellites, copied off of what MDA is flying right now and demonstrating on HBTSS. In Tranche 2, we're flying 6 additional missile defense satellites, in addition to our remaining missile tracking satellites. In Tranche 3, we're likely going to fly something on the order of 40 or 45 missile tracking satellites, and then we would like to fly satellites on the order of maybe 9 that show you can do the missile warning and missile defense, or excuse me, missile tracking and missile defense from the same satellite. We're really interested in hearing from industry on what those capabilities are. So when we make that solicitation, we know it's something that could be produced. So that's also new. That's what you'll see as far as the new space solicitations for Tranche 3.
And certainly a lot.
Yes, it is.
Thanks for that rundown. That was excellent. And I think you've already hit on how you plan with a 5-year design life to make sure that the technology that you're putting up on orbit for operations is the most current as possible. And we don't have the tendency like we do with the traditional satellite that lasts twice as long as its design life, and therefore we're stuck with outdated technology on orbit.
Right. Yes, we have planned obsolescence built in.
Yeah.
So we have 5 years. That's it. At the end of that 5-year lifetime, we will decommission the satellites and move on. Our operation centers, we have one at Redstone Arsenal down in Huntsville, and then we have one at Grand Forks Air Force Base in North Dakota. We have those sized and scaled and planned to be able to fly 3 operational tranches at a time. The whole idea is then you will decommission and you will continue to keep that same footprint. That's built into our entire architecture, which we call the Proliferated Warfighter Space Architecture, the PWSA.
Right.
So that's built in. Now, you did say something I want to caution. When you say the most up-to-date hardware and most up-to-date technology, I will caveat that a little bit, right? It is the most up-to-date, production-ready technology.
Sure.
So we are always trying to make sure that we can buy technology that really can be produced and launched 30 months order to orbit. So we're continuing to push the technology ball down the hill, but we're never, we're never taking that giant leap to really try to push the state of the art.
So that perfectly segues into the next question, which is the use of commercial off-the-shelf technologies that help speed your acquisition process. That also has an impact on the types of contracts you can award. But I think by even fielding an architecture rapidly that uses the available technology, I think you're actually putting technology in the hands of warfighters faster than if you waited to develop the next generation capability and then launch that. Would you agree? That's
right. That's the whole basis behind our spiral development approach. We feel that we When we let a contract, we let that contract 30 months order to orbit, and we choose technology that has a capability level that we think that industry can actually hit those dates and push forward and go. You know, obviously, there is technology that's further along, but you won't be able to build 50 of those satellites in 30 months. That's kind of the idea.
Okay, so we've talked about the industrial base a little bit. SDA recently announced the Hybrid Acquisition for Proliferated LEO. HALO is the acronym. You're not using all the words there, but that's okay. HALO, to expand the pre-approved pool of possible vendors. It sounded a little bit to me like the Space Enterprise Consortium that SSC uses, but can you explain a little bit about this program and why you think it's going to be crucial to ensuring that we have a proper supply base?
Sure. So let's talk about, you know, what problem were we trying to fix with HALO? So if we take this model, the model that we will award contracts based on the lowest risk and the one that has the best schedule capability to deliver in that 30-month time frame. What does that mean? What is the trap? What could you fall into? You could fall into people are always going to bid. You're going to get into this pool where you may have a diverse vendor base, but you're essentially going to have your own. You're going to have 6 or 7 or so vendors, and those are going to perpetuate in time. So it's going to be very difficult for a new entrant to come in with new technology because it'll be higher risk, and you won't be able to, they just won't score well in the source selection. Mm-hmm. So that's a real problem. We recognize that, you know, people in industry have told us that's a real problem. We recognize that. So our way to try to alleviate that, well, we have always said our baseline method is we will put out our technology roadmap. It's on our website. We work with people that are better at technology development than we are, such as DARPA or the Air Force Research Laboratory. And they can also, industry can also invest their own IRAD to develop technology to burn down that technical risk so that then they have an offering that differentiates them on one of the future bids, one of the future tranches. But there are a group of smaller companies that are commercial in nature that are coming up with these commercial models, and they're building satellites, but they may not have the credibility to be a credible vendor for building 50 satellites for us out of the bench.
Okay.
So that's where HALO comes in. HALO is an IDIQ-like contract. Why do I say like? Because it's a other transaction agreement-based consortium, if you will, where people submit their proposals, and then if they won, we had 43 bids, and of which 19 got in this pool. The 19 in the pool will get task orders from us, and those task orders will be to build 1 or 2 satellites, notionally 2, to demonstrate a new capability, new technology on orbit. That's how we'll do our demonstrations. So that is the fastest way that we can get new technology demonstrated on orbit is through HALO. That's mission number 1, demonstrate that technology as rapidly as possible. Benefit number 2 that comes out of this construct is now I have a vendor base that brings in these new companies that demonstrate the capability, get credibility, so now they can bid on a future tranche and have some credibility that, hey, look, we know we can step up to the plate and deliver 20, 30 satellites.
Yeah, so thanks for that clarification, because I was thinking HALO might have been the potential pool for vendors for future tranches, but it sounds like it's for demonstrations, demonstrating new technologies as well as your ability as a company to deliver that.
That's correct.
Okay.
Our tranches, our solicitations for the tranches will always be full and open. Every tranche, every layer will be fully competed. And we want as many new vendors to be able to come in there as possible. We want to keep a healthy vendor base, not only at the prime vendor level, the space vehicle vendor, but also the tier 2 and tier 3, the subcontracts. Keep that vendor base healthy.
Okay, shifting gears a little bit. I talked in the intro about space as a contested domain, and building an architecture like the proliferated warfighting space architecture understands that it is contested and there will be potentially attacks. And that means operating in a communications degraded environment. One of the ways to get around degraded environments is through optical terminals. And I know that you're pursuing optical terminals with Space Development Agency. Aviation Week recently had an article about a contract award with General Atomics for a project called Manhattan. You don't need to go into details on that, but how is the Space Development Agency looking at optical comms? Is it space to space, space to air, space to ground, all of the above?
All of the above. So starting even with, well, frankly, starting with our first demonstration satellites that we launched in 2021, we had 2 Mandrake satellites, and that they demonstrated, they were primarily to demonstrate space-to-space laser communication, did that. And then they also demonstrated that they were able to do space-to-ground pointing, acquisition, and tracking to demonstrate with these small, affordable, low size, weight, and power and cost terminals, we could do space-to-space and space-to-ground. In Tranche 0, and then operational in Tranche 1, those laser comm systems are going to be used for space-to-space, space-to-ground, and space-to-air. We actually chose our optical standard, which is published on our website, that's open because we want a broad base of vendors to be able to build to those. We chose that specifically so that it would work space to air. There's a lot of laser comm systems that you could optimize for space to space. We optimized ours to be able to do space to space as well as space to air. So you make some trade-offs to be able to do that. We did that because we recognize that the spectrum is contested. The enemy gets a vote in contesting spectrum, as well as just getting spectrum approval. Much more difficult in the RF realm than in the optical realm. And so we chose to go with that standard, and that's our future going forward.
Okay. The heart of systems engineering is making trade-offs and finding that right balance. So a little bit further on the optical communications, you mentioned this earlier as well, the link to Link 16.
Right.
Can you talk a little bit about how your laser capabilities fit into the existing architecture with Link 16?
Sure. So just to lay the stage on what Link 16 is and the missions that it provides. So Link 16, the beauty of Link 16, one of our operating modes in SDA is that we do not require a lot of changes to user equipment. Okay. So I said, look, we're going to field a few hundred satellites. Let's take the onus on ourselves to modify those satellites so they can go down to legacy radios. So we don't force the Army, Navy, Air Force to field tens of thousands of new radios, because that's very difficult, right? So Link 16 is a radio. It's a radio platform, radio network that's used by all of our allies, NATO allies, Indo-PACOM allies across the globe. It's fielded across all of the services. There are tens of thousands of these terminals already out there. Our uniformed personnel are already training, already know how to use these systems. So we designed our system to primarily go down to that tactical radio. That's what we'll use. We'll go down to that radio. Our allies will use it. That's our connected in. In the future, right, Link 16 will still be around. Link 16 will be around for decades. But there's a lot of missions that need higher data rate than Link 16. Link 16 was developed in the 80s, for the Cold War scenario, defend the Fulda Gap as the Soviets would be coming across Europe. And so it was designed for just 300 nautical miles, kind of the range, but we bring that now global by bringing Link 16 to space. But in the future, you're going to want to have a lot of aircraft that want to move a lot of data. You're going to want to have ground systems that have this low latency connectivity that want a lot of data connected that you're not able to get with Link 16 or other systems. That's where the laser comm comes in. It's not ever going to be as prolific in a user base as Link 16, which, like I said, there's already tens of thousands of those radios fielded, but we do see it growing, and you'll have thousands of those laser comm terminals in the future.
Yeah, you mentioned Link 16 might be around for decades. If it became compromised and they decide to develop a new capability and then fill tens of thousands of new terminals, it sounds like the model you would follow, though, is we're still going to plug into whatever the current standard is to make sure that we can communicate with the warfighters.
Right. So Link 16 has a lot of different variants, and they continually update Link 16, and we make sure that since you can afford to make changes that allow you to do backward and forward compatibility when you're talking about 400 radios on our satellites. It's more difficult when there's tens of thousands. So we take that on ourselves to make sure that we can talk to all of the backward compatible Link 16 and all of the future Link 16 systems.
Excellent. So you mentioned recently at Aerospace and Cyber, actually, that you wanted to follow the Android model of for optical communications to allow maximum interoperability. Maybe we've already talked a little bit about this, but making sure that not just one vendor can provide that. And this is part of why you publish the standards online. So can you talk to us a little bit about the practices for hardware and software perspective and how that might apply to the future iterations or future tranches?
Absolutely. So the Android model, there's two. When I talk about how cell phones get promulgated and how their infrastructure works, we're trying to model ourselves after that. We try to model ourselves after the cell phone community, not only in that, but also in the aspect that essentially we have we have a fixed price point. And we want to let the community know what that price point is, so they build to that. And we expect the capabilities to increase over time while the price stays constant, very much like your cell phone, right? Cell phones today cost very similar to they did 10 years ago, to what they did 10 years ago, but the capabilities are significantly more. That's what we're doing. Now, the Android versus Apple model is interesting because both models work very well. They're very effective. And the difference between the two, you take the Apple model is actually easier. The Apple model says, hey, look, I'm going to have an ecosystem that I control. I control all the pieces. I control the supply chain. I control all of the interoperability because I own all the pieces and parts. And I integrate that, and I make sure that no one else is building things for that network because it's too difficult to make sure that they'll be interoperable. If I control it, I can make go. You can actually do that model very quickly and very efficiently. The downside of that model is you do get vendor locked into Apple, for example, right? Some other. Right. Whereas the Android model is different. The Android model says, look, I don't care who builds, I don't care who builds an app that goes on my system. I don't care who builds a piece of hardware that goes on my system. All I care about is the fact that I have published standards and I have interfaces. And as long as you meet those interfaces and those standards and demonstrate that you can meet those, then you can build whatever you want behind that black box, plug into my network, and it'll work. The advantage of that model is that now I can actually build up a healthy market, a healthy industrial base to where I can have a lot of competition. The competition gives you two things. One, it gives you better price in the end. And number two, it does give you better capability because you got these people competing with one another. And I believe that competition helps drive the entire market. The disadvantage is it is more complicated. It's more complicated on our side, the government side, because now we essentially have to make sure that we enforce those interfaces and enforce those standards so that everyone can be assured that they work. The way we do that is we have a test bed at the Naval Research Laboratory where the vendors bring their equipment into that test bed, demonstrate they're interoperable, demonstrate they meet all of the requirements of the standard, and then they're blessed and told they can go to production. So those are the two different models, and we chose the Android model.
Okay, excellent. So one of the benefits, though, that you mentioned of the Apple model is control over the supply chain. And so SDA has faced some supply chain bottlenecks regarding hardware, like laser links, for example. So how are you working to make sure that you have a diversified and strengthened supply base? And what steps are you taking to make sure that you can continue to deliver through all of the tranches for future architectures?
Yeah, so it's a difficult thing, and there's a balance because we contract with our primes, and our primes manage their subcontractors, and they're incentivized to hit their schedules and deliver. But it's clear that a lot of the subcontractors, they weren't able to scale up as quickly as they had, and we've been working very closely with them. We have put contracts in place with some of those subcontractors to help incentivize them to build them up. We've gotten involved with them and helped to try to build up their processes, as well as the primes. Some of the primes have sent people to their subcontractors on site to help build them up. The key thing there is to just keep pushing. As we continue to keep pushing and continue to just put these contracts out there, launch the satellites, get the things built, that tier 2 supplier base will build its way up. It's interesting. So Tranche 0, the difficulty with Tranche 0. So Tranche 0 launched about 6 months late, and it launched about 6 months late. Primarily, that you can always point to different things, but I'd say the root cause of the slip on Tranche 0 was the COVID supply chain impacts, where it became nearly impossible to even buy a resistor, let alone space qualified parts. We got through that, got launched, but we did take a little. Now on Tranche 1, we're looking at about 6 months late on Tranche 1 as well. We're still going to hit our 2-year from Tranche 0 launch, which is the goal. But what it looks like there is you're able to buy resistors, but the manufacturers that said we have all of these supply chains coming together and we'll be able to build these things and we'll get up to a production rate of say 10 optical comm terminals a month. Well, maybe they were a little optimistic and maybe they only got up to 7 a month and it's taken them a while to get up to 10. That's causing some of these delays. Okay. So that's where you see this learning curve. Tranche 0 was just getting the parts in hand. Tranche 1 is building up your manufacturing capability, which always goes slower than people anticipate.
Yeah. So you mentioned the fixed price approach, and we talked about using mature technology, which also enables you to pursue fixed price contracting. You're convinced that that's the right approach for this type of
Absolutely.
system. You don't ever foresee changing your contracting approach for large mega constellations like your.
No, I think that the fixed price approach, I think Secretary Calvelli and his tenets for rapid space acquisition spell that out very nicely too, that we fit very well in that with the fixed price approach. Fixed price approach buys you two things. One, it puts the risk on the performer, obviously, is the key thing.
Right.
But the most important thing is not that. The most important thing is it forces the performer to really put together their plan and know that they put together a plan that they can stand behind. Because when you have a fixed price contract that has an order to orbit of 30 months, there's not a lot of margin in there for them to play with and say, well, I can fool myself and I think I can do it for this price and I'll make it up. If you have a 10-year fixed price contract, you might be able to fool yourself. You might be able to bid to the government and say, yeah, I can do it for that price. I'm going to take it. And then you end up losing money because you were overly optimistic. 30 months order to orbit, contractors doesn't have a lot of leverage to be overly optimistic. They really have to put together a bid on something that they truly believe on day one they can execute towards. So it really helps enforce that mentality.
Yeah, excellent. So current U.S. constellations typically have 5 or 6 satellites sometimes. You're talking about hundreds, and that's going to drastically change the way we think about satellite command and control and the operations floor. A group of Mitchelleers, if you will, went up to North Dakota recently and visited your site for operations in North Dakota at Grand Forks, and were very impressed at the facility and the people out there. So thanks for your hospitality there, and great work to that team. But looking ahead to the ground and hardware and software perspective, how do you manage the operations for such a large architecture? What changes are you instituting?
So that is great. We do have great teams. We have great teams up at Grand Forks and great teams at Redstone that have pulled this together. And what we have done from the very beginning is we said we're not going to look at how traditional DoD programs fly their satellites. We're going to take a lesson off of how commercial flies their satellites. Commercial industry, there's a lot of folks that fly constellations for the commercial industry, and most of those are lights out operations with very few operators. So for our Tranche 1 and Tranche 2, we actually have a mission integrator that's helping pull all of this together. And that mission integrator is a team with General Dynamics and Iridium. Iridium is bringing a lot of that experience on how to do this constellation management that's mostly lights out. And so from the very beginning, we had buy-in from the space vehicle vendors that you're going to get 2 seats at the operating center, per vendor. And that's really it. So most of this work needs to be done automated. Needs to be done remotely, and needs to be, you need to be able to figure out how to automate this whole system. And then the GD Iridium team, they have a few seats there to make sure they do the network management and the overall constellation management and such. And then our uniformed military personnel and our civilians that are actually going to be the mission directors that are doing the priority calls and day-to-day, you're talking about a handful. You're talking about just a few of those on staff at any given time to be able to oversee this entire hundreds of satellite constellation. And that's the model we've taken. And then we said, okay, now those are the boundary conditions. Now let's figure out how to operate within those. And the teams did a great job putting all this together and figuring out how to make it work.
Awesome. One of the areas we typically don't associate with Space Development Agency is international collaboration, but certainly that's a high priority for the Space Force. Things like Allied by Design, and I know Air Marshal Godfrey is working on an international collaboration strategy going forward. So how is SDA looking at international cooperation for future architectures?
So that's one of the beautiful things about Link 16. So Link 16 is already proliferated with our allies. So they can use our Link 16 satellites. The networks are all managed by what's called a JICO, a Joint Interface Control Officer. Those JICOs work already internationally to make sure, so they're controlled by the regional combatant commander. And that combatant commander then, that JICO with that combatant commander sets up that network. And so they'll set up a network with our allies on it, with the SDA transport layer on it, and with other US assets on it. So it's transparent and it works across the board. And so that's already built in. The next step is how do we get our allies to actually build pieces and parts of constellations that they may want to own and plug into our transport layer. And that's one of the beauties of these interoperability standards. We say, hey, look, if you want to build some of your own sensing satellites and you want to plug into our transport layer, we'll work with you to make that happen. Here's our standards. We'll work with you to make sure that you can work on and off our network, and we'll be able to move your data. And so we're in discussions with several allies to be able to do that. If you look at our testing campaign, one of the blessings the Federal Aviation Administration has given us is they have given us the opportunity to not test within the continental U.S. And so in doing so, we have a great opportunity for networking with our allies and partners. So all of our testing up to date, all of our Link 16 testing has been done either in Australia. As I mentioned, we're testing this week in Norway with our allies there. And then we've also done testing over the open Pacific. But that's another way where we tie our allies together. Norway has also been gracious and given us ground sites. One of our ground entry points is for Tranche 1 is going into Norway. So we're tied very closely with our allies and partners.
Excellent. So speaking of Norway, very close to the Arctic, during the Cold War, the emphasis was,
it was cold there.
Well, yes, I think it's still cold in Norway. That hasn't changed, although, you know, global warming might have an impact on that. But anyway, the focus during the Cold War between the United States and the Soviet Union was, of course, threats coming over the poles.
That's right.
Right. And threats transiting the Arctic Ocean. What we're seeing or have seen in the past 30 plus years is missile threats around the globe at lower latitudes. And I'm sure that the Space Development Agency architecture is looking at the variety of threats. Are you ensuring that you're still also monitoring those polar threats as well?
Yes, in fact, that's one of the advantages of our constellation, especially Tranche 1, where all of our Tranche 1 satellites are launched into polar orbit, 80-degree inclination, essentially polar orbit, where we get good coverage over the polar region from day one with our Tranche 1 constellation. And we chose that orbit primarily. It's the most efficient way. If you measure efficiency as the fewest number of satellites to give you full global coverage, polar orbits are the best way to do that. So that's why we started with Tranche 1, because we wanted to get global coverage as quickly as possible. And a byproduct of that is we double down on the polar regions.
Excellent, excellent. So we've talked a little bit about the future for the Space Development Agency and how you're already soliciting for Tranche 3. I imagine there's a Tranche 4, Tranche 5.
Yes, there will be.
Over the next 5 years, what are your primary goals for the Space Development Agency? Do you see the role of SDA evolving any over time?
I can continue to see us just delivering on the PWSA. So that's one of the beauties of this spiral development approach is, I can tell people with certainty what's on Tranche 1, certainty what's on Tranche 2, because those are, we're starting to cut metal on that. Tranche 3, more confidence because we have a minimum viable capability that's been blessed through our requirements process, but nothing's on contract yet. And then Tranche 4, the beauty of it is I don't know what Tranche 4 is going to look like. I won't know for about 1.5 years. And that's beautiful because within 1.5 years, threats can change, technology can change, and we are able to respond to that as quickly as possible because we don't make the decision on what's going to launch until 30 months, right? 30 months order to orbit. So we can shift and change around. So if you look at 5 years from now, we'll be at the end of 2029. So Tranche 3 will be operational at that point.
Right.
So we'll be pushing out Tranche 3. Tranche 4 will be deep in build, getting ready to launch. And then at that point, Tranche 5 will be where Tranche 3 is now. So that's the beauty. It just keeps going along.
Just keep turning the crank.
That's right.
Continuing to do your market research and surveillance, as well as keeping track of the threats and how they're evolving to make sure that you're delivering the right capability.
Keep getting those Liberty ships on orbit.
Absolutely. Well, thank you, Dr. Tournear. I really appreciate your insights. So at this time, we're going to open it up to questions from the audience. By now, I think you all know the drill. Aiden will call on you. Be sure to unmute your mic, state your name and affiliation before asking your question. So with that, Aiden, who do we have on first?
First, we have Greg Hadley from Air and Space Force magazine.
Hi, can you
Go
all?
ahead. Gotcha.
Awesome. Thanks, Dr. Tournear, for doing this. My question was on the timeline for the Tranche 1 satellites. Do you have a definitive timeline for when those first launches will happen? And are you still planning on that kind of 11 month kind of cadence of launches to go up?
Yeah, so that they'll launch in the March, April timeframe. So that's kind of what we're looking at now. And the launch cadence is 10 months. There's 10 launches, and they were on 1 month centers. The idea is we're working with the vendors to see if we can't bring that in. Right? We know SpaceX can launch faster than once a month. So we can bring this in. The space vehicles will be ready faster than that once we start the initial launching. But it's just a matter of how fast will it take us to get through launch and early operations and pull that in. But at a minimum, 10 months once we start launching.
So speaking of
Or excuse me, at a maximum.
the cadence between launching and satellite delivery, are you ever concerned that you're going to need to have some sort of storage for satellites that might get produced faster than launches, or do you think the launch rate that SpaceX and ULA and others can provide is going to be enough to just get them as they come off the assembly line? So
Sometimes people ask that and say, well, in fact, you always have to worry program management, right? Program management is more of an art than a science at times. And one of the things that vendors like to do is they like to play the game that I call the race to the bottom, right? And it goes like this: we're race to second place, if you will, and it is. Well, I could get my satellites ready, but the launch vehicle won't be ready in time. So I might as well. And I always take that challenge, and I say, look, you get them ready. If I have to take possession of those and store them in my barn until the launch vehicle's ready, I'll pay you to do that. So let's go. Let's take the excuse off the table.
Very
So
good.
I'm not worried about that.
no excuses.
No
Press forward.
excuses.
Awesome. All right, Aiden, who's up next?
Next, we have Garrett Ream from Aviation Week.
Yeah, my question was just about some details on Link 16 in Norway. To what aircraft were you broadcasting, and what sort of data was being transmitted? And then if you would provide, what sort of progress are you making with the FAA on Link 16?
Sure. So I'm not prepared to talk about which aircraft specifically we're going down to yet. We'll come out when the time is right to tell you all the great details about what's been demonstrated in over Norway. And part of that is out of respect for our partners and things like that who are providing the aircraft graciously. The messages, they're J-series messages. So the way Link 16 works, it's an IP-based network called JREAP-C. And those are kind of messages where, they're dummy messages that we're just making up on the fly and going just to demonstrate that the network works. As far as the FAA, we are making some progress there. The DoD CIO's office at large is kind of leading the charge to kind of work these things through, and starting to get agreements with the FAA on how we can get temporary frequency authorization with guardrails built in place to be able to do some national airspace testing without full EMCF, which is the entire electromagnetic compatibility features testing, certified before that. So we're making progress. It's slow. We hopefully have abilities to do testing over the national airspace in summer of next year for Tranche 1.
Excellent. It's great progress. Aiden, who's up next?
Next, we have Michaela Eastley from Defense Scoop.
Hi, y'all. Can you hear me okay?
Yes, got you loud and clear.
Great. Thanks so much for your time today, Dr. Tournear. I wanted to ask a little bit more about the missile defense mission for Tranche 3 that you talked about. What is the relationship to that and some of the work that you all are doing with fire control capabilities? I know there's a lot of experimentation going on with the Foo Fighter initiative, so I was hoping you could kind of clarify the differences or how they're related to one another.
Yeah, no, the excellent question on that. We have several programs that are focused on what we call the advanced fire control. We have Foo Fighter, we have Tranche 2 Gamma, and we have a couple other things that are kind of in the pipeline to be worked out. The way to think about the advanced fire control, I can't go into the exact targets and things that it's looking at, but it is looking after a class of targets that is not part of the things that would be tracked by the missile tracking or missile defense architecture. So they're outside of that realm, but kind of similar in that threat space. So that's all I can really say about that.
Great. So,
Okay.
Oh, thank you.
And go ahead if you have a follow-up, please go ahead.
No, I'm okay. Thank you.
All right, thanks. Then Aiden, who do we have next?
We have a question from the audience related also to missile defense. Peter Larkin asks, when it comes to missile detect and track that SDA is focused on, is it primarily traditional ballistic missile defense, or missile threats, or does Tranche 1 also look to deal with more exotic types of missiles like fractional orbital bombardment, long-range cruise missiles, maybe low-altitude drones, etc.?
So this gives me an opportunity to quote my good friend, Mr. Rich Ritter at Missile Defense Agency. So he reminds anyone when he gets a chance to talk that there are almost no ballistic missiles anymore. They all jinx and janks, as he says. So all missiles are maneuverable at some point nowadays. Pretty much that's kind of the standard. And that's the reason for the tracking constellation, is to be able to detect those maneuvering vehicles. If you're going to say, what is the pacing threat that the tracking system was really designed to go after? It's the hypersonic glide vehicles, those maneuvering hypersonic glide vehicles. So that class is really what it's designed to go after. The missile defense satellites can see things a little, that are even more dim than the hypersonic glide vehicles, but that gives you a sense of the class of vehicles we're looking for.
So when PWSA rolled out, a lot of people were associating the proliferation with the proliferation methodology of increasing the resilience of the overall architecture and saying this is in response to the threats to assets in GEO. But there's operational mission utility in going to that lower orbit as well in terms of sensitivity and timeliness of detection, correct?
That's right. That's right. So it's sensitivity. You can't really argue when you're 40 times closer to the target. That's an increase in sensitivity of about 1,600 times. So that's a big deal. So you can definitely use that. That's what enables us to do this mission with these smaller, more affordable satellites. Is the ability, since you're closer, they can be smaller and have the same kind of sensitivity or even better sensitivity than the larger satellites up at GEO. That's number one. And number two is that full global for low latency, right? There's a reason that that Starlink satellites went to low Earth orbit versus doing SATCOM, that they were, satellite internet from
Right.
GEO. And you really do get a lot of that half-second transit time to GEO. You get away from that when you're in LEO, where you have that rapid communication cycle.
It's almost like the perfect storm of the threat from a missile perspective, the threat to space capabilities, the advancement of technology, the availability of lower cost COTS that you can now leverage, and launch rates all really coalesced just in time for PWSA to become a reality.
That's right. So if you look at, historically, the Department of Defense was the primary customer for a lot of space missions,
Right.
majority of space missions. And so the most efficient way, if you measure efficiency off just straight cost to get these global missions covered, it was to go to geosynchronous orbit with these large satellites, and the Department of Defense pushed that technology. In the 90s, there were a lot of companies that came out that tried to do technology based on low Earth orbiting satellites, but the technology just wasn't quite there yet. Now, about 10 years ago, 10 to 15 years ago, the pendulum swung, technology opened up, and it really became a lot easier to do these missions in low Earth orbit. You can argue why that came. If you start to look back, most of it actually probably stemmed from affordability of cost. You can't shy away from the fact that now launch costs are significantly cheaper than they used to, thanks to SpaceX and such. That really dropped the price of launch, which allowed a lot of these smaller companies to get involved in developing technology for low Earth orbit. And because of that, the Department of Defense is no longer driving the key technology in space. It's these commercial companies. And so that's what we capitalized off of, to say, let's use those same technology and just modify it slightly for defense missions.
Excellent. Thank you. Aiden, back to you for the next question.
Next, we have Courtney Alden with C4ISR.
Hi, yes, thanks for taking my question. Just to follow up on the earlier discussion around the Tranche 1 launch date, you've said before that there were some issues with Tier 2 and Tier 3 suppliers, vendors there. Can you, what progress are you making on that? Can you talk at all about kind of what some of those issues are? And then also, how confident are you that the March-April timeframe will stick?
So the vendors. The vendors were primarily we had our laser comm vendor suppliers, and our encryption were driving critical path on almost all our vendors, and that's now ironed out, so that the production rates that were were predicted, they're now hitting, right? So our optical comm terminal vendors are hitting their production rate. So we have high confidence that the schedule we have now is going to hold. The encryption devices, again, they're now starting to hit their production schedule. So we have high confidence that they'll come in. We're working very closely with the NSA because that's obviously a piece of that to make sure we get the approvals for those encryption devices at the same time. Barring all of that, we have high confidence that now that we're hitting our production schedule, we're going to hit those launch dates. Because we're starting to coordinate we are no longer in the stage where we're watching the tier 2, tier 3 providers send their components in. We're in the stage where we have hot lines of satellites under production, and they're being built now daily. And as those components come in, they're being integrated in. So the error bars on when that launch date have gone down significantly now that we're in full rate production.
Yeah, and the more you do, the more efficient it will become, and the more consistent it will become.
Right. I mean, something could break during test.
Sure.
And you could always have a delay during that. Those kind of things may occur. So you don't have a crystal ball to say for sure 100%. But at least I can say that the production capacities are now hitting what they predicted, and we're getting the components in on the time scales that were predicted a few months ago.
Okay, excellent. Aiden, I think we have time for a couple more questions.
We have a anonymous question in Renin. They ask, can Dr. Tournear say anything more on the PNT capability demo in Tranche 3? SDA has described plans for a navigation layer in the past. Will this be the start of that?
Yes, so the navigation layer itself is actually started in Tranche 1, where we do what we call communications nav, comm nav, where we embed that signal into our communication network. So that's already baked in. Tranche 3 will be the first time that we broadcast independently. And right now, the details of that are still being worked out. We're working very closely with the Army because the Army is the one that would be fielding the receivers for these things. And so I can't go into more details primarily because it hasn't firmed up until we get more alignment with what the Army actually wants us to demonstrate and fly on Tranche 3. But it'll be a very small signal in LRS band that we'll demonstrate.
Well, certainly we've seen in Russia's invasion of Ukraine and even in the conflict with Israel that GPS jamming is becoming quite prolific. And we know that countries like Russia and China have significant GPS jamming capabilities. So anything you can do to provide an additional signal for PNT, I think, helps the end users. You mentioned the Army as a primary customer, but
Right.
it's not just the Army who uses PNT, the Air Force, the Marine Corps, the Navy, they all could utilize these types of signals if they have the right equipment. Is that correct?
That's right. That's right. I use the Army. The Army is the one we're closely tied with on the PNT. There's an alternative PNT group, within the Department of Defense that studies and comes up with a way forward. But I use the Army as the leader for this because they have the most fielded receivers. And so, you go after the one the one that's bringing the numbers to the fight. That's the Army.
Fair enough. Okay, Aiden, another question, please.
Morgan Harper asks, is SDA working with SSC at all to support the CASR concept and allow potential future commercial satellite reserve members to route data through the transport layer?
So the CASR concept, the SSC has the lead. We're in a supporting role. We're there to support as needed. The commercial routing through the transport layer is something that we have been working directly with the commercial companies, and we're working with SSC, their comm group out there, because that is a way that we think this can be enabled. As I mentioned before, we have contracts with companies to be able to move their commercial ISR data onto the transport layer and show that could be fused. It's actually, from a technical perspective, that's actually pretty straightforward. They meet our standards. They fly a satellite that meets that. We can plug in. That's actually part of the Titan concept. That's one of our task orders on Halo. So that's actually one of the first task orders that was awarded. It's called Titan. Went to Kepler, Kepler Space System. So they're on contract to build a satellite, 2 satellites that act as what I used to call translator sats, but now the proper term within the Space Force is space exchange points. So these are points that can take data in from commercial and or other systems and then broadcast those to our transport layer and back and forth. So to get the physics of that to work is fairly straightforward. To get the authority to connect with various infosec boundaries and such, that's something that we're still working out. And we're teamed with SSC to look on what that would look like.
So earlier we talked about the optical links between space to space, space to air, space to ground. The answer was all of the above. With the transport layer being this sort of backbone of communications for anybody that can plug into it, does that include satellites at higher orbits at some point in the future as well, potentially?
Yes. So our optical comm standard 4.0, which is what we're looking at for at least some of our Tranche 3 satellites, has a mode on there specifically to be able to switch back and forth so it can talk to the MEO track custody satellites. So SSC is building out, we're building out the low Earth orbit missile tracking satellites. SSC is building out the medium Earth orbit missile tracking satellites. Optical comm terminal standard 4.0 has a mode that can talk to MEO, between MEO and LEO, so that we can move those tracking data back and forth.
Excellent, excellent. Okay, Aiden, a couple more questions?
We have another question from Garrett Ream of Aviation Week.
Yeah, my question is about the alternative PNT again. You mentioned munitions. Does this mean this alternative PNT system would be accurate enough to use for precision long-range fires, or is this more navigation-based sort of system? You know, what would it be?
So the quality is not going to be the precision of the signal is not going to be what you expect from GPS, but it won't be significantly far off that it couldn't be used for different missions like that. Like I said, a lot of those details are still being worked out, and it's very dependent on the number of satellites in view at each time, what the geometric dilution of precision on how accurate you can get.
So it's going to follow a very similar architecture of GPS, multiple satellites providing a signal to a single user that triangulates its position from those locations. So, all right, and one more question, please.
Elizabeth Frey asks, how do you see vendors from allied countries potentially supporting future Tranche missions?
So right now, we for primes, we rely on U.S. primes. Now, some of our U.S. primes have foreign vendors, and we take those at a case-by-case basis on which components, which parts are being supplied, and how we work through those. For example, that was one of the concerns that some of our allied partners had on Halo, is that we only allowed U.S. companies to be considered in that pool. What we would prefer is if our allied partners want to fly their own constellation that fits into the PWSA, they can build that out using whichever vendors they want, and then we'll work with them to tie them into the PWSA.
Well, with that, ladies and gentlemen, we've come to the end of this Schriever Spacepower series. I'd like to thank Dr. Tournear for joining us today and for your insight. It's always great to talk with you. And for all of you for joining us, thank you for your participation and continued support of the Schriever Spacepower series. From all of us at the Mitchell Institute, have a great Spacepower day.